Okay, so today in section 5, we're using completing the square. And we've looked at this first trinomial and said that's a perfect square trinomial, right? And then we said, look at the binomial factor would be x plus 3 squared. So we have the square root of x squared is x, the square root of 9 is 3, and 3 times x twice is 6x. So what could we do if we didn't have a 9 here? How could we know, looking at the middle term, what c should be in order to create a perfect square trinomial? What could we do with 6 in order to find the 9 we need, Dina? Add 6 to it? No. Jocelyn? Kelly?
Take two numbers that add up to 6 that make perfect squares.
Okay, so there's two numbers that add up to 6 that make a perfect square. Or we could take how much of 6 and square it? Half of it. So we simply can take half of this term and square it, and that gives you a perfect square trinomial. Okay? So the goal of today is to turn any expression that you have, x squared plus whatever it is, bx, into a perfect square trinomial, which is ax squared plus 2ab plus b squared, in order to factor fast. That's the goal today. And we call this taking any binomial like that and adding the term that would make it a perfect square. We call that completing the square. Complete the square. We can take any quadratic equation and solve it by completing the square. Okay? So just as we said, for any term x squared plus bx, this should be an x up here, by the way, we simply take half of b and square it. So b over 2 and square it. And this should be moved over a little bit. And we add that to the term that we had. When we do, we can then factor the perfect square trinomial into the square of a binomial. And it's always tougher to look at in this form, in the form of a rule. So we'll be doing a lot of samples so you can see this with real numbers. But we're taking half of b and squaring it to complete the square. Okay, so let's use what we've just talked about to complete the square. Right now we want to find the c value that can help us make a perfect square trinomial. Okay? And then we'll factor the perfect square trinomial, which always results in the square of a binomial, or the squared binomial. Okay? So go ahead and try this first one. What should c become so that we have a perfect square trinomial? Do you see that? Everyone, write it down, jot it down, jot it down. And then once you have it, factor it into the square of a binomial. Okay, so what should c become? Summer.
C should become. Sorry, I tried to remember.
Good. So half of 8 is 4, and 4 squared is 16. So c is 16. And so now, as the square of a binomial, what do we have? Summer, the square root of x squared?
4.
Good. And the square root of 16 is 4, and the sign is positive, so there you go. Okay, good. We're going to use this to solve some equations in a few minutes. So how about when we have a negative second term? What c do we add that would make this a perfect square trinomial? Talia. Good job. She says 36. So we could write this as x squared minus 12x plus 36. Because half of 12, half of negative 12 is negative 6, and negative 6 squared is 36. It's always going to be a positive we're adding due to the squaring of it, right? So Talia, when we look at this as a square of a binomial, how would you write it? Good. The square root of x squared is x. The square root of 36 is 6. And then because the center is negative, we have to have subtraction in this binomial. So x minus 6 squared. Good. And the last one, x squared plus 3x plus c. So what are we going to add to both sides? Here, Tara. How do we find it? What was the process? Do you remember?
You divide 3 by 2.
So you would get 3 divided by 2, and then you would do what to that?
You'd square it.
You could square it, square the whole thing. And so we're adding what? You can leave it as a fraction right now. What is 3 halves times 3 halves? 3 times 3? 3 times 3? 9. 2 times 2? So you could call that 9/4. What is 9/4 as a decimal? 2.25. You could call it that if you want. Your book tends to leave it as a decimal. So they would call this 2.25. I like 9/4 because we're about to create the square of a binomial, right? And so what is the square root of x squared?
X.
And the square root of this term is? Up here it's 1.5, down here it's 3 over 2, right? You could actually write it as 3 over 2, or 3 over 2 is 1.5, and then the sign is positive. Okay? Good, so we can do this even with tricky numbers that are not even. If we're dividing by 2, we might get something with a half. Okay? So how do we use this to solve a quadratic equation? Let's look at this first one. This first one is very straightforward. As a matter of fact, we could solve this first one just using our plain old-fashioned factoring that we've done before. So how did we solve quadratic equations? Let's do it the old way. This is our old way over here. And then we'll do it by completing the square in a moment. But what did we do with all equations when we were trying to factor them? Maddie?
You'd set it to 0.
Good, so we would subtract 7 from both sides, right? And we would get x squared plus 6x minus 7 equals 0. Now, is this factorable?
Yes.
Are there factors of 7 that subtract to give you 6?
Yes.
It's negative, so we're subtracting them. So yes, there are. It would be x what?
Plus 7
X minus 1. Good. And so because we're being asked to solve it, we actually give the values that would make this statement true. And so the value for x in the first binomial would be?
7.
What?
Oh, negative 7, sorry.
Negative 7. And then here,
And then
1. Okay, so we already know the answer to the question, solve this, but we didn't show completing the square. So let's show completing the square. Okay? So if I were to subtract the 7 from both sides, does this trinomial give you a perfect square trinomial? No. So instead of subtracting the 7, we're going to leave it right where it is. And we're going to find something to add to the binomial here to create a perfect square trinomial. So, JD, what will we add to make this a perfect square trinomial here?
We're going to add 6 over 2, which is 3. 3 times 3 is 9.
Good, adding 9. Now, when we're adding 9 to an equation, on the left side, what must we do? Add 9 to the right side in order to maintain equality. Okay? So, good. Now we can factor. We have a perfect square trinomial. So what is the binomial factor for this? X, good, plus 3. And what is 7 plus 9?
16.
16. Good. Now, how did we learn in the last section to deal with a squared term like this? What can we do? Take the square root. Good. Take the square root. And so on the left side, the squaring and square rooting cancel out, and you have x plus 3 equals, what do you have on the right? Wait a minute, two things.
Oh, negative and plus 4.
Plus or minus 4. Don't forget two things. Okay? So now to finish this, what do we do to the left side? And we're going to do it to the right side as well. So this is how we might write it. We could say I have positive 4 minus 3, and I have negative 4 minus 3, right? I have two things here. What? No, we can simplify this. What is 4 minus 3? 1 and negative 4 minus 3 or plus negative 3? Negative 7, which totally agrees with what we found by factoring. Okay? Now, usually we don't use completing the square when you could factor it like this. This is just so straightforward, right? But I wanted you to see a sample where we know what the answer should be and look at using this method can get you there too. Okay? We're most often going to use this method when we can't do this. We can't factor, but there are solutions and we need to find them. Okay? So here we have a couple more to try. And as a matter of fact, this one right here answers that question. This one right here, number 4, if we subtract 3, we actually could factor that the old-fashioned way. But I want you to use completing the square. Okay? But in this one here, if we add 8, are there factors of 8 that add up to 10? No, this one's not factorable the old-fashioned way, but it is solvable using completing the square. Okay? So pause and come back and see what we found here. Okay, so you will need to pause the video and walk through this step by step. We've created a perfect square trinomial each time, adding the same value to both sides. We took the square root, giving us plus or minus in both cases, and then we had to find the two solutions. So, okay, what about if we have more going on in the equation, like this? Notice that the first term with a perfect square trinomial, the first term has to be a perfect square. So in this case here, 3 is not a perfect square, and it isn't here as well. So it would be a lot easier if we could let that first term equal 1 and just worry about the last terms here, right? So starting with number 6, if we wanted that first term to be 1, what would we divide by? 3. So divide everything by 3, all sides by 3, and we end up with g squared minus what? Good. Plus 27 divided by 3. 9 equals 0. So do we now have a perfect square trinomial? We have g squared, we have 9. Is the middle 2ab? No, because if it was, what would that number be? Square root of 9 is 3, 3 twice is 6, right? So this is not a perfect square trinomial. So we could try factoring the old-fashioned way, but what factors of 9 add up to 8? 9 and 1 add up to 10. 3 times 3 adds up to 6. They're going to have to both have the same sign, right? Negative 9 and negative 1, right? In order to give us a positive. So no, you can't. So what do we have to do with that 9? Subtract it. Good, from both sides. Okay, leaving room so that we can use the completing the square. So Arthur, what do we have to add to both sides?
So to both sides we should add 16.
Good. Now, how could you write that as a square of a binomial?
So then we need to add negative 9 and 16, which gives us 7. And for the other one, it's g minus 4.
Good. So now what do we do to both sides? So we have g minus 4 equals the square root of 7, which is approximately plus or minus 2.6 is what we found in the last class. Okay? And so now when we add 4 to both sides, we end up with g could be
6.6.
or negative 2 plus 4, which would be 1 point. It's positive 1.4. Okay, because the 4 is bigger. I'm going to pause. You'll have to come back and look at the last one worked out by pausing the video. Okay, so you'll probably need to pause the video and walk through the steps for number 7. We divided out the 3 and found that we could not factor this. It was unfactorable, so we moved the 6 away and found 4 made it a perfect